Alright, so in this video, I'm going to really show you how to use this protractor, which is also in the shape of a half circle. Now you can see that I have numbers all over this protractor. There's numbers on the bottom that look like a ruler. There's numbers on the very, very bottom, which again looks like a ruler. And then you have numbers that are going in that half circle motion with 90 degrees in the center, and then it continues on. And you notice that there's numbers on the top and on the bottom. So if you notice on top, it goes from the number 10, and the numbers increase and become greater and go all the way to that middle 90, and then continue on to go all the way to 170. Now again, the reason why it's only showing you 170 and not 180 is because this isn't the end of the protractor. This is the end of the protractor right here, this bottom-most line, and that is your straight angle, which would be 180 degrees. But if you knew that you were dealing with a straight angle, you wouldn't need to really use this line. And that's why they don't label it. Then on the bottom, instead of the numbers increasing, they're actually decreasing. So you're now going from the number 70 all the way down to the number 90, and you're continuing to go down all the way to the number 10. And so that's just to kind of give you an idea of how a protractor looks. And we're going to talk about why the numbers on the top and the bottom are different and how you know which one of those numbers to look at once we really start measuring these angles. So in the previous video, I showed you guys what the 3 or technically 4 types of angles there are. You have your right angle, which is exactly 90 degrees. You have an acute angle, which is less than 90 degrees. You have an obtuse angle that is greater than 90 degrees. And you have your straight angle that equals exactly 180 degrees. Now, to know which one of these numbers on this protractor we are going to use, we want to first identify which type of angles we're dealing with. So I'm going to look here, and I can see that this is pretty much a straight, well, I wouldn't say straight, but it's pretty much, it looks like it's 90 degrees. So I'm going to label this as a right angle, and I'm not 100% sure if this is a right angle. I won't know until I officially measure with a protractor, but I'm going to just take a guess that this could very well be a right angle. If you look over here, I can see that this is greater than 90 degrees, and again, you can just use your paper. You can match your bottom up and make sure that your vertex is right in the corner of your paper, and you can make yourself that dotted line to see that you are in fact greater than 90 degrees. So I'm going to label this as an obtuse angle. I don't know the exact measurement of this angle, but I do know that it is greater than 90 degrees, so it's obtuse. Down here, this definitely looks less than 90 degrees, but I'm just going to double check with my piece of paper. So when you guys are using a scrap piece of paper, this is the best way to help you identify what type of angle you're dealing with if you're somebody that may not be able to visually see it without doing that. So this would be my right angle. I am definitely less than that right angle, less than 90 degrees. So I'm going to say that this is probably an acute angle. Don't know the exact measurement yet. We'll find out, but I do know that it is less than 90, so it's an acute angle. Now this angle you can see is facing in opposite directions of what the rest of them are facing. And I just want to make sure I'm looking at it correctly. And I can see that it's probably less than 90 degrees. Again, I'm just going to make that dotted line to kind of give you guys a better understanding of why I know for certain that this is less than 90 degrees. So this would be my exact 90 degrees. This is less than 90 degrees. So I'm going to label this as an acute angle, not knowing the exact measurement again, but I do know that this is smaller than 90 degrees. Now here you can see that I have a straight line on the bottom that I'm now turning into. And I have this ray up here, and this right here would be its vertex. And I want to measure this specific angle. I don't want to measure this angle, but I'm going to measure this angle. And to me, this looks less than 90 degrees. And again, I'm just going to double check by making sure that I can match this up. And you can see that it is in fact less than 90 degrees. So now what I'm going to do is I'm going to take my protractor You want to make sure that the numbers are facing the correct way. You don't want your numbers to be backwards. So you're going to make sure that all the numbers are facing the right way. And you're going to take a look at this bottom part of our protractor, and there's this hollow hole that I can kind of stick the tip of my pencil through. So this is where you're going to match this up to the vertex, which is where your two rays meet. Two rays that meet at the same vertex create an angle. That's what makes an angle. So we're going to match this middle circle up to this middle dot. And then we're going to make sure that these black lines are matched up to my bottom ray. So I'm going to match that up real quick, and I'm going to make sure that that's as even as possible. And you can see that my ray is extending all the way up, and I can look at these tick marks up here, because what these do is they give you a better understanding of where you are on this protractor. So I can see that I labeled this as a right angle, but it doesn't look like a right angle to me because it looks less than 90. It doesn't look like it's greater than 90. And just so I can double check and make sure that it is in fact less than 90, I'm going to match this up. And again, remember that once you match it up and you make that perfect corner, it makes it easier for the eye to see. And I probably should have done this first, but I am in fact less than 90 and not greater than 90. So I was wrong on my prediction that this was a right angle. This is actually an acute angle, and we're going to find out its exact measurement. So I'm going to put this back up. I'm going to make sure that my middle part is right on my vertex and that this bottom line is matched up. This is right where 90 degrees is, but I'm not hitting right 90 degrees. So I'm going to count over. I'm at 89. I'm at 88 degrees. So this is an acute angle that measures 88 degrees. And so I'm going to change the way that I labeled this by putting a half circle, because the other symbol means that it was automatically a right angle. So I'm going to come over here. I already know that it is obtuse because I used the corner of my paper to measure what the exact 90 degrees would be. And I'm going to again match my middle hollow circle on top of my vertex where my two rays are meeting. And so I want to make sure that this bottom line is not just straight while I look at it, but it's matched up again. So you kind of want to tilt this protractor. You want to make sure that that line is matched up with your bottom ray. And again, I can see that this goes all the way up, and I can see those tick marks. And since I know it's an obtuse angle, and I have labeled up here that an obtuse angle is greater than 90 degrees, I am now going to look at the larger numbers. And I didn't really specify that on the last one, but I'm going to show you what I mean. So at the top, you can see that there are smaller numbers, and at the bottom, you can see that there are bigger numbers that are greater than 90. So we're going to look at the bottom in this case. We're not going to look at the top. And I know since these numbers are increasing, I'm going from 100 to 110 to 120 to 130. I'm somewhere between 130 and 140. So I'm greater than 130. I'm less than 140. And I'm going to mark down what I'm closer to. So I know that this line is the line for 140. So this is 139, 138. And it looks like I'm somewhere between my 139 and 138. It's a little hard to distinguish because this arrow is hitting right at 138. So I'm going to say it's 138 degrees. But it could also be 139 degrees. But I'm going to stick with this. It looks closer to 138. And so this is an obtuse angle that measures 138 degrees. So now I'm going to measure this acute angle. And again, you're going to match this dot up with this vertex where those two rays are actually meeting. You're going to make sure that your bottom line is matched up with your bottom ray. And you can see again that my top ray extends all the way. So just in case you encounter an angle that maybe has two very short rays, and you're trying to match your protractor up, I want you guys to understand that you can use this protractor to extend your line. Right now, if I were to look at my eye, I wouldn't be able to judge exactly which tick mark this is on. So you want to take your protractor, you want to match it up, and you want to extend your line to give yourself a more accurate measurement. You want to be as accurate as possible. So I'm going to extend my ray, I'm going to match it back up, and now you can see I'm exactly on a line. It's perfectly visible that I am now on a line. And you could do that with the previous ones to make sure that it was 138 degrees and definitely not 139 degrees. But in this case, I'm going to make sure that I'm extremely accurate. And now since I labeled this an acute angle, and I know that an acute angle is less than 90 degrees, I'm going to look at the bottom numbers here because the bottom numbers are all less than 90 degrees. So these numbers in this case are decreasing. I'm going from 90 all the way down to 10. So I'm somewhere in between 40 and 30. I'm definitely greater than 30, definitely less than 40. So in this case, I'm going to look at where that middle point is. Right here, I know it's kind of hard to see in the video, but this is 35 degrees. So I know that I'm past 35 degrees. Again, I'm less than 40. So I want to mark over right here. This is exactly 36 degrees. So this is a 36-degree angle. Again, you can see here I have another acute angle, which is less than 90 degrees. So in this case, again, you want to make sure that your protractor is matched up. You want to make sure that your protractor is lined up perfectly. So I'm going to tilt my paper to make this easier for me, myself. I'm going to put it right on my middle vertex. I'm going to match that circle up. I'm going to make sure that that bottom black line is matched up with my bottom ray. And I'm going to extend this line a little further because I liked the accuracy that I got from the last time I did that. So I'm going to extend it a little further just to make sure. I'm going to match it back up. And now since it's an acute angle, it's less than 90 degrees. Once again, I'm going to look at the bottom numbers because I'm going from 90 all the way down to 10. These bottom numbers are all less than 90. So I'm somewhere greater than 40, but I'm less than 50. And since I'm closer to the 40 mark, I'm going to mark down that 40. And you can see I'm just 1 over from 40. So I'm actually at 41 degrees. So this is a 41-degree angle. So now I'm going to measure this part. Remember, I want to measure this side of my last angle. And I didn't write it down, but we did say that this was an acute angle because it was less than my 90-degree mark. So I'm going to turn my paper once more. I'm going to match this middle part up with the vertex. I'm going to match that bottom line down to my ray, and I'm going to extend this line further just to make sure that, again, I have the most accurate measurement that I possibly can. I'm going to match it back up. It only takes a few seconds. And since this is an acute angle and it is less than 90 degrees, once again, I'm going to use the bottom. So this time I'm greater than 50, but I'm less than 60. Right here I have my 60-degree mark. Right here I have my 59-degree mark. And right here, which is where my line is, I am at 58 degrees. So this is a 58-degree angle, and it is for sure an acute angle. So I hope this gave you guys a better understanding of how to use this handy dandy protractor. You won't always get to use this protractor, but it's good to use it now so you can kind of feel out the measurements of different types of angles. So you're going to take your own protractor, and using this video, you guys can replay this as much as you need to. You're going to use this protractor to measure angles on a separate worksheet to see if you guys kind of get the hang of it. But I hope you guys enjoyed this video. Thanks for watching.